Good day everyone and welcome back to the Azure Databricks series. In today's video, we are going to explore one of the most effective ways to reduce costs in your Databricks deployments using job compute instead of all-purpose compute. We will dive into what job compute is, how it works, its advantages, disadvantages, and when it's best to use it in your Azure Databricks environment. Let's start by understanding what job compute is. In Databricks, there are primarily two types of compute, all-purpose compute and job compute. All-purpose compute is used for interactive notebooks and it's optimized for data exploration, ad hoc queries, and collaboration. However, it's not always the most cost-effective solution for scheduled or automated workloads. This is where job compute comes in. It's designed for bad jobs and is more cost efficient because it's optimized for running scheduled tasks, production workloads, and long running jobs. Job compute will start when a task is submitted and will be deallocated once the task is completed. Databricks units or DBU bar h will be less for job compute when compared to all purpose compute. Now let's talk about the advantages of using a job compute. Since job compute is optimized for non-interactive long-running tasks, you are only charged for the time the compute resources are actually in use. Unlike all-purpose clusters, which may stay active even when not in use. Job compute automatically scales up when a job starts and shuts down when the job is done. Job compute can scale horizontally by adding more workers when needed and scaling back down once the task is complete. Job compute is optimized for automation. It's built specifically for scheduled jobs, making it ideal for production workloads like ETL processes, scheduled reporting, and batch data processing. While job compute is fantastic for certain scenarios, it does have a few limitations. Yeah, it is not suitable for interactive workflows. Job compute isn't ideal for real-time exploration, collaborative notebooks, or environments where data scientists need to iterate quickly. Yeah, also job compute cannot be used during development phase. Yeah, during development phase, we will have to write different queries and we will have to check its efficiency. And all these things needs to be done on an all compute cluster, which allows you to run ad hoc queries and things like that. It doesn't have any direct UI interaction. Yeah, you can't manually intervene or interact with job compute clusters once they are running, as they are designed to be fully automated. Yeah, it's kind of less flexible. All-purpose compute provides a more flexible environment for different types of workloads. But with job compute, you are limited to specific job-based use cases. Now let's look at the Databricks pricing. Yeah. So if you see here, as far as the workload is concerned, we will compare between all-purpose compute and the job compute. Yeah, and we have a premium tier services. So if you see here, per hour, the DBU per hour is costing close to INR 46.179 for all-purpose compute. But if you look at the job compute, for the same DBU per hour, you are getting charged close to 25 rupees dot 189 paisa. So now, if you compare it, I can tell that the cost for job compute is almost 50% less than the all-purpose compute. Yeah, maybe like 48, 49%. But yeah, if you see here, the all-purpose compute, you are charged 46 rupees for the DBU per hour, and for the jobs compute, it is just 25 rupees, 189 paise DBU per hour. So this provides you a lot of flexibility as far as the cost optimization is concerned. Once you have a mature notebook and you want it to be schedule that needs to run every day, every hour, whatever the requirement is, you need to switch from your all-purpose compute to job compute and make sure you are using the job compute, and that way you will be able to get the better of Databricks, and also like you can lower the cost associated with executing it in the Databricks. Yeah. Moving on. Um, So let's discuss when should you choose job compute over all-purpose compute. Yeah, let's talk about some ideal scenarios. Yeah, so now let's consider you have a scheduled ETL workloads. If you have regular ETL jobs that run during off hours or scheduled at specific times, job compute is the way to go. For job compute can be used for any kind of batch processing. For large scale batch processing tasks, job compute will automatically scale and reduce costs by only charging for the time it's actually working. It is suitable for non-interactive jobs. Yeah, if your jobs don't require real-time interaction or manual interventions, job compute is the better, more cost-effective solution. Now let's move on to see how you can set up and use job compute in Azure Databricks. I'll walk you through the process of creating a job compute cluster and configuring it for your scheduled jobs. Yeah. So now what I'm going to do is for this particular demo, I'm going to use this particular notebook, which is called one dot process underscore storage underscore finance data. Yeah, this is the notebook that I'll be using. To be frank, there is no way you will be able to create the job compute manually. Yeah, it needs to be invoked from the ADF when and where it is required. Yeah, you can't just create it from the UI, the workspace, Databricks workspace UI. Yeah, let's head to our Azure Databricks studio. Yeah, now let's first create a link services to our Azure Databricks. Let's click on new here, and then let's go to compute and select our Azure Databricks. Now let's name this Azure Databricks. Let's name it as LS, which is link services, Azure Databricks underscore job compute, just to identify that. Okay, let me select my Azure subscription. Now I will select the required Databricks workspace. Yeah. So I'm going to select JBSWiki Databricks. Okay, now comes the important thing. In my all my previous videos, I've been using this existing interactive cluster. Yeah. So in this demo, I'm going to select this new job cluster. This is what I'm going to select. Yeah. Okay, so I've selected this new job cluster. Yeah. Okay, so we need the access tokens. Let's go to the workspace. Yeah. And then click on our profile icon and then click on settings and then go to developer and you have the access tokens here. Click on manage and then let's create a new token. Okay. The comment is like Databricks job compute demo, and then I will keep the lifetime as 900 days, and then you need to copy this and then use it here for the access token. Yeah, so now what I'm going to do is I'm going to select the clustered version. Yeah, here I'm going to use say I'm going to use 15.4, whatever version you want, you can select it. I will select maybe 14.3 LTS photon. Yeah, 14.3 LTS photon includes Apache Spark 3.5 5.0, Scala 2.12. I will select that. Cluster node, what I'll do is like I will select this DS3 V2, yeah, and then Python versions I will leave it to 2. And worker type, what I'll do is like right now we have this fixed, but I will select auto scaling. Let's look at what informations we have. Yeah. So auto scaling enables the cluster to automatically scale between minimum and maximum number of nodes based on the node. Single node cluster consists of a driver but no workers. Yeah. So I don't want fixed. I will select the auto scaling. So minimum workers I will have 1 and maximum workers I will have 4. Okay. And now what I'll do is like I will leave everything else as default and I will click on test connection. Yeah, I just want to make sure that the access token that I have used is right. The connection is successful. So let me create it. And the link services that I've created is basically this one, which is ls underscore Azure Databricks underscore job underscore compute. Yeah. Now I have this. Now what I'm going to do, I'm going to create a new pipeline. Yeah. Let's create a new pipeline. It's going to be very simple. The most important thing here is to understand the job compute. Yeah. Let's click on done here, and then let's go back to this compute. Yeah. And then we will click on this job compute now, and then let's go back here, and then I will name this pipeline as pipeline underscore Azure Databricks job underscore compute. Okay, so now what I'm going to do is like I'm going to create I have the pipeline. So now what I'm going to do is like I will use this Databricks workflow, and I will make sure like I will execute the notebook that I've created. Yeah, so I will name it as one dot um, so one dot notebook finance data execution. Yeah, okay, I will use it as notebook underscore finance data execution. Yeah, Azure Databricks, I will use the link service, which would be my ls underscore Azure Databricks underscore job underscore compute. Yeah, let's do a test connection. All good. So let's click on settings here. Yeah, and then I will go to this notebook path and then click on browse. I will click on users, and then I will select my notebook, which is one dot process underscore storage finance data. Let's click on OK. Yeah, so this is added now. Now what I'm going to do is like I'm going to publish it. It's published now, so I will validate it once. And then what I'll do is like I will trigger it. Before triggering it, if you see here, I don't see any job compute here. Yeah, there are no computes. So now let me trigger it. Let's click on view pipeline run. It's currently in progress. Now if you see here, as soon as this particular package started, we have this job compute created. Previously, we did not have any job compute, but now if you see here, we have a job compute. Yeah, let's click on that. And then if you see here, we are using 14.3 LTS, Apache Spark 3.5.0, Scala 2.12. And if you see here, we have this 1 to 4 workers that we have selected. And also we have this one driver. Yeah. So now if you see here, we have this DBU units, which is 3 to 10. Yeah. And if you can see here, we have this job cluster currently processing our job that we have created. Yeah, let's go back to this and then let's click on it. So let's wait for it to complete. Yeah, so it's currently in progress. The thing is, like, the time taken is as soon as this job cluster is created, the underlying VMs, everything needs to be provisioned, and then you will have to execute the notebook. So that is the reason. There are certain things that you cannot use in job compute. Yeah, the things like you have a strict SLA where you need to have the job run as soon as possible. Yeah, in case if it is a very critical notebook and you can't have any delays, then you can't use the job compute. Yeah, but as far as jobs that are not with strict SLAs and the jobs that are going to run for several hours, job compute is really going to save you a lot of cost. Yeah, in terms of performance, it is just going to be same as the interactive cluster, that is your all-purpose compute. But the only difference is like the time taken for provisioning the required cluster as far as the job compute is concerned is going to be little high when compared to all-purpose compute, because all-purpose compute is always ready. Yeah, it all depends on the inactivity time that you have given. Yeah, for the all-purpose compute, even in all-purpose compute, if it is stopped and if you have to start while the job is running, it's gonna take time. But if it is already running, then it will be like starting the job right away. But as far as the job compute is concerned, it has to basically provision the required cluster, and then it has to execute the notebook. Okay, so if you see here, it is so the state is like running now. Yeah, the job cluster. Now let's look at this pipeline here. Yep, it's still executing. Let's wait for it to complete and we'll take it from there. Okay, so it's still executing. Yeah. So now if you see here, the run is completed. Yeah, let's look at this one as well. Like what is it executing? Okay, if you see here, it took close to 20 seconds to complete. Yeah, the execution of this particular code took close to 20 seconds to complete. Yeah, it comes out with the proper output. And if you see here, it basically tells like this is the pipeline that we have used and this got executed. Yeah. Now looking at the Azure Data Factory here, let's refresh it. And if you see here, it has succeeded. Yeah, it has completed. Now, if you look at it, it took close to 5 minutes to complete this package. Yeah, but in reality, that actual script took close to 20 seconds. So that means like close to 4 minutes, 30 seconds we spent in the job compute cluster. Yeah, this is the kind of delay that we might see, and you just basically have to weigh between the completion time and the cost, and at most of the time you will select the appropriate workload for the job compute. Yeah, now let's go back to here, and if you see here, the job is finished. Yeah, so we don't have anything running now, because as soon as the job finished, this cluster gets stopped and it will be deallocated. So yeah, and if you see here, this is what we have completed as far as the ADB is concerned. Yeah. Now let's click on this, and if you see here, is the same thing that we provided. That is, the min workers is 1 and max worker is 4, and everything seems same as what we have configured in our ADF for the job compute. You can either view it from the compute here, the job compute, and you will be able to see that, or you can click on this job runs. Yeah, and if you click on this job runs, you will be able to see what is running. And now currently we have this job completed. Yeah, so it took close to 4 minutes. 4 minutes 55 seconds. Okay, let's click on that. Yeah. And now if we look at the job run, ADF underscore JBS Wiki ADB SI is our um, Azure Data Factory. Yeah, if you see here, JBS Wiki ADB SI is our Azure Data Factory. Yeah, and pipeline ADB job compute. This one, that's our um, pipeline name. Yeah, pipeline ADB job compute. Yeah, and then the notebook that we are executing is this notebook finance underscore data execution. So we have this notebook finance data execution. And then this is our activity ID. So if you see here, this is the activity run ID V0F. V0F. So this is how you basically check the job compute and understand which pipeline, which notebook is getting executed. Yeah. Okay, so once this completes, yeah, the job compute cluster will be deallocated and will be decommissioned in some time. So once the job completes, you will not be charged anything for the Databricks compute. Yeah. Thank you for watching. Don't forget to like, share, and subscribe. And that wraps up our video on effectively using job compute for cost optimization in Azure Databricks. I hope you found this video helpful. If you have any questions, feel free to leave them in the comments below. Don't forget to like, share, and subscribe to the channel for more content like this. Thanks for watching. Have a great day. Jai Hind.